So hi everyone, today we would be looking at caching. In the previous video we already looked at like how availability works, how latency and throughput works, how storage part works. So in this part we need to look at caching because caching is a very essential part when it comes to system design. So we will take a very simple example of a library. So whenever you go to library, you must have seen that there is a librarian sitting there who provides you with the books. So let's say this is the library, and every time someone comes to the library, and asks librarian for a particular book, so librarian goes to the shelves. Here you have multiple shelves, so the librarian goes here and gives back the book. But every time the person takes around the librarian take, let's say, 5 minutes, and there are hundreds of people in the queue. So don't you think this is going to take a lot of time? Obviously it will take a lot of time. So let's consider another scenario. I will just remove this part, and let's say the librarian has a library, and this is the shelf where the librarian goes. But this time when there are hundred of people, the librarian stores a small shelf around it and keeps the book which are actually lot of people are requesting for it. Let's say there are five books which are very popular among the people. So the librarian is keeping those books with it. When a person comes and asks for a particular book, the librarian will first look at the nearest shelf and see if that book is already there and give back that to the person. So this way, the librarian will take only 1 minute for per person. And if the book is not found, then the librarian will go here for 5 minutes. So this way, librarian is showing so much of time for all the people. So what can we actually understand from this? So from this we can understand that we don't need to do the task which is actually preloaded in our system. Similarly, memory works. So I will just erase this and let's take a new example. So let's take an example of client server data. So you have this client, obviously the same thing that was present in the server model. Then let's say you have the server, and at the end you have the database. This is the database. So every time you know exactly what is happening. The client says to server, servers go to database returns to server, and server returns to client. This is what happens. But let's take an example that I am the client, and the database server is for Pokemon.com. Okay, so every time I request the server to fetch me the home page for Pokemon.com, it will go to the database or take all the images and everything, and it will serve me the home page. But what if I say that Pokemon.com has a very static page, like it never ever changes. It remains the same. The home page always remains the same. So you would say me that okay, then why do we have to fetch it every time when you are an often user of that Pokemon.com homepage and the content remains same? So we will take some space here in the server and we will store that in our server, that particular Pokemon.com homepage. And every time now I will go here, the server will say, okay, I already have that page, and it will return me. Just imagine how much the efficiency has improved. This task is removed. You are just going to server and it is returning you. So this is what caching looks like. So coming to the definition of caching, you can think caching like a very basic term where a piece of hardware or software that stores data, typically meant to retrieve data that faster to us. So caches are often used to store responses to network requests. As you saw here, the network request was going from client to server and then database. So that's how caching works. Now there are 2 to 3 terms that are very important to caching. Like I will just go here and let's take the laser. So when caching is going to server and when the requested data is found in this server, then this is known as cache hit, that the requested data is found in cache. But suppose I go to Pokemon.com and I say that okay, I didn't found the data that I wanted, and server says okay, we need to fetch it from the database because that is not present there. So this is known as cache miss, when requested data that could have been found in a cache but it is not found. This is typically used to refer to a negative consequence of a system failure for a poor system design choice. So let's take another example. So if a server goes down, let's say if the server goes down, now a load balancer will have to forward the request to a new server. Suppose there is a new server here, so the load balancer is here and you go here. So now when this server is down, the load balancer will redirect us to here, and Pokemon.com is not in this server, so it will return us that cache is missing and we will have to go to the database for fetching it again. So yes, this is how things work. But there is a catch. Now just imagine if there is this server and then there are clients, then you have another client, then you have server, then you have another client, you have server. Okay, and this is the whole big database. And I will just change the color. Yes. So it requests here, similarly, and yeah, it returns back. Same for this. Let's name this C1, C2, C3. Now suppose on Pokemon.com we have videos, and on videos we have comment section. Now in comment section, obviously anyone can write anything. Now client 1 oftenly goes to watch this particular video number 7 on Pokemon.com. Now what server will do, it will do the caching for the comments part. So obviously as you cannot cache the video because it is of 300 MB, let's say. So let's say the server has cached the comments part because it's not changing. But one day a client 2 comes and just makes an edit to a comment. So when client one day sees that, okay, let's look at the comments now, and it sees that the comment has been updated. So has not been updated because the client 1 server cache is not been updated by the database. So client 1 will respond to that particular comment on Pokemon.com's video, and that is not a good thing because client 2 has already updated the comment. So same thing will happen for client 3. It will see one day that, okay, the caching has not been done, that, okay, client 2 was saying something else, but client 1 has responded entirely something else, because for client 3 the client 3 doesn't know that, okay, client 1 has updated the comment, and like client 2 has updated the comment and client 1 is not aware of that. So this will result in a malfunction, and this is not a good practice at all. So for handling these kind of requests, there are a lot of caching algorithms. One is LRU, that is known as the least recently used. So it will only cache the things that have not been recently used. Same goes for FIFO, like first in first out, and it will only cache the things that were inserted first and not the latest things. Same happens for least frequently used, LFU. So the thing which has been least frequently used will be cached, something like that. So the policy by which values get evicted or removed from the cache is totally dependent on these 3 types of algorithm. Means there are a lot of algorithms, but yeah, for this video you can consider these 3. Now there is a concept you have already heard of, CDN, which is content delivery network. So content delivery network, it acts like a third party service that acts like a cache for your servers. Sometimes web applications, can become slow for users in a particular region if the servers are located in another location. So a CDN has servers all around the world. So you can think like this. Suppose the Pokemon.com has server 1 in India and 1 in US. Now in India, there is Pokemon.com has been cached in this server, and in US also it has been cached. So what will happen? Every time Pokemon.com is being hit, it won't go to US. It would first go to India, check if this is present here, and then return it, because it will save a lot of time. So 2 most often like content delivery networks are, you must have heard already of, are the first in Google Cloud, GC, and then you have Cloudflare. So these are very famous 2 algorithms, web services that provides content delivery network caching. So coming to the benefits of caching, you must have got to know till now, but let's write. So the first benefit is obviously speed. Commonly requested books are retrieved faster in the first example as we talked about. Then we have reduced load. So the archive area for our is accessed less frequently, preserving its longevity and reducing the chances of a bottleneck problem. There are some challenges still. As I told you, there was this thing that was happening here, that okay, one person has done this, but another person is not able to retrieve it. So these are some problems that are being faced, and this particular problem is addressed as the data is becoming stale. The data is becoming stale, like it has been updated but it is not being shown in other clients versions. So this is how caching works. In the next video we are going to look at how proxies work, and let's see how things go there in proxies part. So that is it from my side. I hope you have got an idea about how caching works, what is caching, and what are the general terms used in it. Thank you and have a nice day.